All right, so we have an idea of how to increase our percentage of odds of getting an interview. We also learned about Big O notation and how we can use it to look at our code and analyze whether it is efficient or not. Using our knowledge up until now, let's move to another important topic. At the end of the day, an interview is a way for the company to find out, can you solve problems that the company or employer has? Because if you're able to solve their problems, then you're valuable and you will produce more value to them than the salary that they're paying you. That is what a technical interview tries to answer. Now, we can be smart and strategic about where we apply and how we apply to a company, and we learned about that in the previous sections. But here comes the big challenge. You got an interview. What do you do? Over the next couple of sections, we're going to tackle this question and get you as prepared as possible for the coding interview. And we're going to get very technical. I know up until now we haven't seen that much code, but we're going to get into the nitty-gritty details over the next couple of sections. But before we dive into coding problems, data structures and algorithms and all of these fun coding details, we must first understand this one principle: how to solve problems. You see, if we know every single algorithm in the world, inside and out, you know all the data structures, you're the best coder in the world, well, it doesn't guarantee that you will succeed in a technical interview. This section is meant to prepare you so that you have the foundation laid out, so that after this, all you need to succeed in the technical interview is the actual coding aspects of the questions. You see, it's not the smartest interviewer that gets hired most of the time. It's the interviewer that is able to answer this fundamental question. Will you solve the company's problem? If you're a genius, but you can't talk to people, you don't work well with others, or you write ugly code that people don't understand, or you can't communicate a solution to a problem, then you won't get a job. You see, it's not necessarily about the solution to a problem in a coding interview. It's about the thought process and knowing the trade-offs between data structures and algorithms, space and time complexity. Just like in real-life coding, you don't memorize things. You have to deeply understand them, understand the trade-offs. So that's what we're doing here. I know I'm taking a long time to get to my points, but we're trying to build the fundamentals before we dive in really deep so we understand the why of each thing. We're building this foundation by first understanding the Big O, which we did in the previous section, and then learning how to solve these problems. In this section, I'm going to show you step by step what we need to do to solve problems in a way that companies really like, so that you succeed in this coding interview. We're going to look at some sample coding interviews from Google and see what they did and what is the ideal process to ace this interview. So that once we have these foundations, we can use data structures and algorithms to solve our problems. Because the interview isn't about your ability to memorize data structures and algorithms. Most people make that mistake. And interviewers can detect right away who actually knows these things versus just memorizing them the week before the interview. So, how can you ace the coding interview? In this section, we're going to talk about the technical interviews and how to succeed in them. I'm going to show you what a successful interview at Google looks like, and then break everything down step by step as to what you need to do. I will also give you a nice little cheat sheet to summarize everything in this section so that you can always view it before an interview. At the end, we're going to solve a coding problem ourselves, just like you would in an interview, and analyze different solutions to that problem based on what we have learned up until now. We're going to figure out the best way to solve the problem, but also analyzing different Big O solutions when it comes to space and time. By the end of this section, you're going to have a big aha moment. I guarantee it, where we're going to take everything we've learned up until now into our data structures and algorithm sections to really understand the trade-offs. Let's get started, shall we? So what are companies looking for? Most people tend to think it's just coding skills, but as you can see here, there's actually 4 things that they're looking for. One is analytic skills. That is, how can you think through a problem and analyze things? And when you're coding during an interview, they want to hear your thought process and how you go from not knowing the answer to solving the problem. They're also looking at coding skills, which is, do you code well? Is your code clean, well organized, readable? They also want to obviously know their technical skills or technical knowledge. That is, do you know the fundamentals? Did you just memorize things? Or do you understand the pros and cons of different solutions? And then finally, your communication skills. Does your personality match the company's personality? Can you communicate well with others, with a team? Most likely, you won't be working by yourself. You're working with others, with other teams, with bosses, with managers. And they want to know whether you're the type of person that's going to fit well and work well within the company. Again, most people get hung up on the idea of learning every single algorithm, data structure, doing 1,000 problems to practice before an interview. And these are important. But in most companies, you won't actually need to know how to write a binary search tree or write a sorting algorithm from scratch. I mean, we're going to go through that in this course, but most of the time, you learn it on the go, on the job, when you actually need it. And let's be honest, as engineers, we know that most of the time, when a problem presents itself, we're good at searching the web on Google for answers. Not a single one of us has everything memorized in our head. Companies know this. They're not dumb. What they're looking for are people who know how to look for answers. And they want to know that you know your data structures and algorithms, and you know of their existence. That's the key. They want to know when you should use a certain data structure over the other. Why should we use a certain algorithm over another? At the end of the day, companies want smart people. They want people that can solve problems that they cannot solve themselves because that's what they're paying you. And having worked at companies and also hiring people, it's surprisingly hard to find people that can solve problems themselves without holding their hand or walking them through a problem entirely. So moving forward, I ask of you to just do this one simple thing. Do all the exercises in the course, pause the videos if you need to, rewatch the videos if you need to. You need to understand the why of doing things. Why are we learning this? Why is this the answer to the problem? Why is this answer better than the other? Again, don't worry, we're going to practice this muscle throughout. Okay, let's dive into the next video to see what we're going to learn. I'll see you in the next video. Bye-bye. In order to solve coding problems, we need to learn these data structures and these algorithms. It doesn't look that bad, does it? Here's the big secret. There are a lot more data structures than this, and a lot more algorithms than this. But just like when you learn a new language, you don't read through the dictionary and learn every single word in that dictionary in that language. Instead, you focus on being able to communicate with others. You only focus on things that are being used most of the time. And when it comes to data structures and algorithms, these are what you're going to get asked on in interviews because these are the ones that get used the most. And 90% of the time to solve a really complex problem, you're only using these things. Doesn't look that bad, does it? All you need is the baseline skills. And companies just want to know that you've prepared for the interview and can succeed within their system. A lot of people complain about coding interviews or whiteboard interviews and how useless they are because they never use some of these algorithms or data structure in their day-to-day job. But they're just a way to weed out people that aren't willing to work hard. Look at this as an advantage. Not many people work on their interview questions. You're going to work harder than 99% of the people out there because you know that getting a good job will have a big impact on your life. And I mean, that's why you're taking the course. And as you see here, the good news is that it's not as hard as you think. You just have to put your time and effort into the right things. As long as we learn our right data structures, when and why to use them, how to implement them, how to solve problems with them, and same with algorithms, and we combine it with our cheat sheet that I'll create for you, when we compare our code that is readable, that is memory efficient, and time efficient using Big O. Between these two, that's all interviews are. That's all coding interviews ask for. If we go back to our outline of the course, we're now getting into the technical interview section. And when I click over here, it's going to look overwhelming at first. And we're going to go over this diagram so it all makes sense. We're going to talk about different data structures that we have. Let's zoom in a bit here. You can see we're going to talk about arrays, trees, stacks, and graphs, and a lot more. We're going to talk about the big O of each one of these data structures. We're going to talk about different algorithms, when to use what. And like I said, this is going to look overwhelming at first, but we're going to go through this step by step so that at the end, all of this makes sense to you. We're also going to use the cheat sheet right over here to help us solve these coding problems. Now, in this cheat sheet, we've already covered the 3 pillars of good code. We already talked about what skills the interviewer is looking for, but we haven't talked about this part. So let's start with this section in the next video. Welcome back. We're going to do a fun little exercise here. Now, instead of me just reading off what I wrote, I have a little ask for you. You're going to use this cheat sheet and look at the step-by-step through a problem, which is a 15-step guide of what you should do when you're in a coding interview to solve a problem. And I want you to use this as you watch a little video. Now, this video is actually produced by Google, and it demonstrates, it's 24 minutes, so it's a little bit long, but it demonstrates how you should answer a coding interview. And in my opinion, this is the best coding interview that I've ever seen. Now, I want you to watch this and keep in mind that because we haven't learned data structures and algorithms yet, this is going to be quite difficult for you to understand. And that's the goal here. When you watch this, it's going to be really, really hard to follow the actual coding, maybe some of the language that they use. I believe they're writing the code in C++. So if you don't know C++, it might be difficult, but that's not the point. The point for you here is to watch this video, but also read the step-by-step through a problem and see how the interviewee, in this case, in this video, follows these steps. And these steps are what you're going to do when you solve a problem in a coding interview. The fun thing is that at the end of this course, we're going to revisit this video. And you're going to notice a difference from this very first time that you're going to watch this video to the very end, where what the interviewee does becomes second nature. You understand what they're coding in, what they're doing to solve the problem, and all these little steps, so that I succeed if you completely get this video and you understand how to run a successful interview at a company like Google or any large company, or maybe even startup, depending on what you like. So to get started, I'll be right back. You go watch this video, you follow the 15 steps, and after this, we're going to do a little problem of our own and follow the guide, the 15-step guide to solve our own little problem. I'll see you in that one. Bye-bye. Welcome back. By this point, you should be familiar with how a typical successful coding interview should look like, especially how to solve a problem in front of an interviewer. And we're going to do a fun little exercise here. An interviewer just asked us a question. And this is the question right here. Given two arrays, create a function that lets a user know, true or false, whether these two arrays contain any common items. For example, if we had two arrays here, one containing A, B, C, X, and the other one Z, Y, and I, it would return false because there's nothing common between these two arrays. However, in this example, array 1 and array 2 both contain X. And because they have a common item, it should return true. So an interviewer just asked you this question. How will we go about solving it? Well, let's go step by step through our little guide. When the interviewer says the question, write down the key points at the top. Make sure you have all the details. Show how organized you are. Well, in this case, I've kind of done this for you over here. Ideally, you would write this out as you are coding and make sure that you show the interviewer, okay, if I had this example, it should return false. If I had this example, it should return true. Now, let's say the interviewer only gave you these points and no other information. At least now you have an idea of what our problem is going to look at and whether we want to return false or true. But we have two things that we want to do with our function. One is we have two parameters, and this function is going to return true or false. Now, in the second point, make sure you double check. What are the inputs? What are the outputs? Well, we've kind of already done that, and we've confirmed with our interviewer that we have two inputs, which are arrays. We can even ask the interviewer that, are they always going to be arrays? Is it possible that the input might not be arrays? Maybe an object, maybe a string. And we can confirm with the interviewer what those cases are. In our case, let's say that the interviewer says that these two parameters are always going to be arrays. And we always want to return true or false. And number 2 is really important here because we don't ever want to jump straight into coding. Even if you think you know the answer or you've seen this problem before, you know exactly what to do, don't jump straight into coding. First, explain your approach, like I'm doing here, talking it out. Because if there are any problems with your approach or with your understanding of the question, your interviewer is going to often point them out to you here before jumping straight in and looking at your code and saying that, no, this is wrong. This way, both you and the interviewer know exactly what the steps are that you need to follow. Now, let's look at point number 3 here. What is the most important value of the problem? Do you have time, space, and memory to run this function? What is the main goal? Now, because this is a simple question, we might want to ask the interviewer how large this array is going to get. Because if the interviewer says the array is never going to be more than 5 items, well, then maybe we don't have to worry about big O or time complexity or space complexity as much. And then you can ask the interviewer, is our goal here to be as efficient as possible with our function? What's more important to us? Is time complexity more important, or is space complexity more important? Maybe the interviewer might tell you that we just want the most efficient function that you can come up with, assuming that the array can get very, very large. So let's say in here we have 2 parameters arrays that have no size limit. So these arrays can get really, really big. And in terms of returning true or false, that's all we want. We just want a Boolean return. Now, number 4, don't be annoying when asking too many questions. And we're kind of getting to that territory where we've asked a lot of questions to the interviewer and we kind of have an idea of what we want to do. We can keep asking them questions, but remember, you usually have a time limit. You don't want to keep bothering them and annoying them and just asking them all these small little questions before we start coding. Keep time in mind. And I think at this point, we have an information that we can move on with our assumption to start solving the problem. So number 5, start with the naive brute force approach. First thing that comes into mind, it shows that you're able to think well and critically. And you don't even need to write this code, just speak about it. This is always a case when an interviewer asks you a question. They usually have an easy solution that we call the brute force, which is not the most efficient, but usually is the easiest one or the first one that comes up in mind. So in our case, if we look at this, during an interview with a time limit, you might say, this looks like a nested loop where we're comparing A with Z and then A with Y, then A with I, and then we go to B with Z, B with Y, B with I, and then so on and so forth. So immediately this looks like we're comparing 2 different arrays, and we're going to have 2 for loops, one nested on top of each other. And right away, we know that that's a big O, which we've talked about, of O n squared. Most likely during an interview, nested for loops is something that we want to avoid. Just telling the interviewer this solution, even though it's not the best solution, already shows that you're thinking clearly about the problem. And it also gives you a point from where to improve from. Now, you don't necessarily have to code this part, and it's usually enough just to describe how it works, kind of like I just did now. But depending on your time, you may or may not want to code this as well. The important thing is that you let the interviewer know that this is the brute force or the easy, naive solution that may not be the most efficient. At least this way you have the right answer, than running out of time and not even having an answer. Number 6 here is tell them why this approach is not the best. So in our case, we said that the code might be not efficient, or we might have not readable, or a code that is going to be really complicated and hard to read for other developers. With my demonstration, because I just want you to think about this so I can be more clear of why this is O n squared, I'm going to just code, and most likely you wouldn't do this in an interview. I'm just going to code the brute force solution so you can see what I mean. I'm going to have a function, and this function is going to say contains common item, and it's going to receive 2 arrays, array 1 and array 2. Now, we are going to take the first array and do a for loop. So I'm going to say for let I equals 0. And we'll say that as long as I is less than the array1.length, so that's the length of the first array, we're going to increment I. And within this loop, we're going to have another for loop. So in the first time around, we're going to grab A from the first array, and we're going to compare it to the second array, Z, Y, and X. So we're going to have a for loop here, and we'll say that we'll have the same thing. This time, instead of I, we'll say J equals 0. And this J, as long as it's smaller than array2.length, it's going to increment every time we loop through it. And finally, within here, we're going to do a bit of a comparison. We're going to compare A to Z, then A to Y, then A to X. So if I go over here and say if array 1, index of I, so array 1 at index of I, so the first time around, I is going to be 0. So that means array 1 is going to contain A. Let's actually grab this so we can see it better. At the top over here, I'm going to have two arrays here. And we're going to say that array at 0 first time around is going to grab A. And if that equals array 2 at whatever j is the index of array 2. So first time around is going to compare it to z, so a and z. And then as this increments, it's going to compare it to a and y. And then this is going to increment, compare a to x. And then we go to the top loop again. I gets incremented, so it becomes 1 now. So we're going to start comparing b to z, b to y, b to x, and then c to z, c to y, c to x, and so on. If that's the case, and if this is true, we just want to return true. Otherwise, if we loop through this and this never matches, well, in that case, we can just return false here. Now, let's see if this works. I'm going to just say contains common item, and we're going to give it the two arrays, array 1 and array 2. If we run this, and let's make this a little bit smaller so you can see, if I run this, I get true because there's a common item of x. If I change this to now have r and I click run, I get false. Again, if we change this to a and click run, we get true because a and a match up. Looking at this, and we look at number 6 over here, that is, let's make this screen a little bit more organized so we can read this. Number 6 says, tell them why this approach is not the best. Now, again, you might not have time to even code this, but we can right away see that we have two for loops, one nested after another. And because we've already talked about this in the big O section, we know that we have a big O when it comes to time complexity here of, well, we have an array A and another array. So that means multiply by B. Again, this is a bit of a trick because these two arrays can be different sizes. We can't just say O(n) squared because these two arrays can have, again, like I said, different sizes. So this is a bit of a trick, and it's a good thing that we wrote it out because now we see that instead of O(n) squared, this is more like OA times B. If the array sizes are the same, they'll be the same as O(n) squared, so that's pretty slow. So number 7, walk through your approach, common things, and see where you may be able to break things. Any repetition, bottlenecks like O(n) squared, or unnecessary work? Did you use all the information the interviewer gave you? And so on and so forth. Now, looking at this, I can say that we could probably do better. You might not see a solution right away, and that is because you need to practice a few of these problems to understand a common pattern. But one of the most common patterns when it comes to nested for loops is that you might be able to use something called hash tables, which we'll get to. In JavaScript, they're called objects, in order to speed things up. Is there a way to turn this OA times B time complexity into something faster? We are doing a bit of unnecessary work where we just keep looping AZ, AY, AA, and then we go BZ, BY, BA, and we're doing this comparison in the same work over and over. What if we have a better solution? I'm going to comment this out for now and scroll all the way to the bottom, and we don't need this anymore, and try a different solution. I'm going to bring the array down here just so we can see it. Now, before we start actually coding, let's think about what steps we want to take. Well, what if we had a function that takes the first array, so let's say array 1 is going to be converted to an object. And this object is going to contain something like this. It'll contain, and let's make sure we comment this out. It's going to contain A equals true, then B equals to true, C equals to true, and then finally it's going to have X equals to true. Now, if we create an object like this, we can now use this object with our array 2 to just say, array 2, can we check each item in array 2 to this object and see if a property exists? Ideally, we can do something like array 2 index and see if this equals any of the object dot properties. Okay, let's walk through this one more time. This is a common pattern that you're going to see a lot when it comes to improving time complexity. So if you don't get this right away, don't stress out. This is something that will become more and more familiar to you as we do more problems. But if I'm able to convert the first array into an object that looks like this, now instead of having to loop over both arrays, I can just loop through the second array and just simply check if the property z exists on this object that we created. No, it doesn't. Does the property y exist on this array? No, it doesn't. Does the property a exist on this object? Yes, it does. That means we have a common item. Now, to show you how this actually works and why this solution would be better than the first one, I need to actually start coding it. But as we go through number 8, we see that before you start coding, we want to walk through your code and write down the steps you're going to do. So let's start doing that. I'm going to say that we're going to create a new function, contains common item. And this one I'm going to add 2 because it's our second function. It's going to take in an array of 1 and array 2. And now this function, let's make this a little bit smaller so it looks nicer. There you go. This function is going to say, first, I want you to loop through first array and create object where properties equal items in the array. And then the second thing will be to loop through second array and check if item in second array exists on created object. Now, before we even start coding this, I can right away sense that we're going to have a better performance than the first array that was O, A times B. Because what we're going to do is have 2 loops, but these 2 loops aren't going to be nested. Remember, in the first solution, we had nested for loops. In this solution, in our second solution, we're going to have 2 separate for loops. And if you remember our big O analysis, when we have steps one after another instead of nested, the big O becomes A plus B. We have a potential solution here, have a time complexity of A plus B instead of A times B. Those are big savings. We need to start actually writing this code to see if we can solve this problem. And because this video is getting long, we're going to do this in the next video. But I want to show you right here what we've just done. And that is, although we haven't given a clear solution, we've been talking about how we solve the problem. The interviewer sees how we think, sees what steps we take, and sees that we're making smart, critical decisions to go from understanding the problem to solving the problem in a naive way, understanding why this might not be the best way, and then start to think about possible solutions. And the beauty of this approach is that no matter whether we get this part correct, maybe our assumptions are wrong and we can't do this. We're showing the interviewer that we're thinking through a problem and we're making small logical steps towards a solution. And this is a lot better than just coding right away, trying a solution and see if you get it right or wrong. An interviewer is going to have a good understanding of your abilities and your thought process this way. And these are the type of people that they want to hire. So in the next video, let's finish out this problem, let's code it, and see if we can make this solution more efficient by converting it to OA plus B. I'll see you in the next one. Bye-bye. Welcome back. Let's get back to where we were. We want to start actually writing our code, keeping in mind that the more you prepare and understand what you need to code, the better the whiteboard will go. So never start a whiteboard interview not being sure of how things are going to work out. So we've talked it out. We have a plan in mind. Let's start to code this. Let's do the first loop over here. That is, we want to loop through the first array. And let's remove this code just so it's a little bit cleaner. We want to loop through the first array, create an object where properties are going to match the items in the array. I'm going to create an object. Let's just call this map. And this map, we've created it, but we want to loop through our array. So I'm going to say let I equals 0 and we've done this before, I is less than array1 dot length. We're going to increment I. Now within here, we're first going to say if there is no property, so we want to check whether map.a exists, map.b exists, map.c exists, map.x exists. So if that doesn't exist, in JavaScript, we can just use this syntax. We can say if no map I. So again, if map I, which the first time around is going to be A, so if map.a is the opposite, so this exclamation mark in JavaScript means the opposite. If map A exists, it's going to return true. If it doesn't exist, it's going to say false. So this might be a little bit confusing, but we want to say if this doesn't exist, in that case, we want to do something. Now, the way if statements work in JavaScript, it needs to be true in order to execute whatever's in here. So we add the exclamation mark here to turn false into true. I know that can be a little bit confusing. You can read up on it, but essentially what we're doing is we're just checking for the property, if it exists or not. If it doesn't exist, then we're going to add it. So I'm going to say const item equals array1 I. So that is A. And this item is going to have map item equal to true. What did we just do here? Well, we said if map A doesn't exist, in that case, let's make array1 I, which is A, equal to item. So map item is going to equal to true. All we're saying is map A, in this case, equal to true. So by the end of this, we're going to have an object that is going to have property A true. And we're going to keep looping through it until we have an object called map that has all these items, map A, map B, map C, map X equals to true. All right, it looks like we're able to achieve this. And we can just console.log here just to check what we have. I'm going to say console.log map. If I run this function, let's do contains common item 2, array1, array2. And let's minimize this a little bit so we can see. And if I run this, I'm going to make sure I spell that right, array2. Let's run. We see that we have A true, B true, C true, X true. Awesome. So now we have that working. Let's go through the second step. And actually, I just noticed here that this, the way it is right now, is checking I, which is 0, 1, 2, 3. But instead, we want to check A, B, C, X. So instead of I here, it should be array1, bracket notation I. So that is A, B, C, X as the property of the map. Lots of brackets here, but I hope that makes sense. So if I run this, we should still get the same answer. Perfect. Now, let's look at the second part here. We want to loop through the second array and check if the item in the second array exists on the created object. This should be fairly simple. All we need to do, and let's remove the console.log map here. All we need to do is to loop over the second array. Let j equals 0. J should be less than array2.length. And then we're going to increment j. And all we're going to say is if map, what do we want to check? Well, we want to check if it contains the first item in the second array, that is z, as part of its properties. Remember, our map object contains these properties. So all we're going to say is we're going to check the array2, and we're going to check the j index. So the first index, 0 over array2, is going to be z, then y, then a. And if that's true, if it does contain those things, because remember, when we evaluate this, it's going to return true if it exists. If not, we're just going to get undefined. We're going to say return true. Otherwise, at the very end, we can just say return false. Okay, let's see if this actually works. I'm going to just click run. And I get true. Okay, so I see that A and A match. What if I change this to something that doesn't exist, like R? If I click run, I get false. What if I change this to C? I get true. If I get this to X, I get true. If I change this to W, I get false. Awesome. So we've just coded something new, a new function that, if we look at, makes things possibly better, right? Because we have two for loops, one after another, which is OA plus B, versus before, where we had nested for loops, which was OA times B. At this point, we can tell the interviewer, if the arrays are substantially large and we can get really large arrays, then this solution, when it comes to time complexity, is better. How cool is that? Now, let's go through the next steps because we're not actually done yet. Let's make this a little bit bigger. Number 11 is think about error checks and how you can break this code. Never make assumptions about the input. Assume people are trying to break your code and that Darth Vader is using your function. How will you safeguard it? So always check for false inputs that you don't want. But essentially, I now look at this code and say, how can I break this? Well, let's think this through. If I go through this code and let's say, what if I have two A's here and I run? Does this still work? Okay, what if I have A and A here? What happens? All right, I get true, that's good. But what if I have a number here instead of a string? We just assume that the array is going to contain strings. I get false. Okay, what if I do 1 here? I get true. Okay, so that works. What if I do an empty array here? Okay, I get false. What if I do another array here? Okay, I get true. What if I do null here in JavaScript, which is a little tricky? Okay, I get false. What if I do null? I get true. Okay, that works. If we go back to what we had before, we want to now tell the interviewer how we might be able to break this code. For example, what if we don't receive a second array? What if this function is called with just one array? What happens? Oh, we get an error. We want to start thinking about how errors might arise. We want to make these functions as error-free as possible. And during an interview, you usually won't have time to do all the checks that you want, but you might want to tell the interviewer possible solutions or possible ways to go around this, such as, can we assume always 2 parameters in the function? Is what happens if in the second parameter I pass 0? Okay, I still get false. What if I pass null? Oh, I get an error that says I can't read length of null. So you want to start thinking about and maybe discussing with the interviewer how you may break this function and how you may improve it, such as doing checks, such as if statements, to make sure that what the inputs you are getting are what you are expecting. Now, this is when testing comes in and testing your code comes in. During most interview, that's usually beyond the scope of the interview and you have limited time, so you can't do this, but it's good to tell the interviewer what you would do. This is one of those things that it's simple enough that you can just tell the interviewer this is what you would do versus coding it, and they will essentially give you full marks for it. Let's look at the next step. Don't use bad, confusing names like I and J. Write code that reads well. Now, when I look at this function, it's okay. Now, I say don't use variables like I and J. And although I'm using I and J exactly here, this is being used for loops. And for loops, using I here is okay because it is a bit of a standard, especially in JavaScript. And these are just simply indexes. But perhaps if these parameters had meanings, such as maybe this was the user array and this was the items array, naming these as more useful, more meaningful variables or parameters might be better. Maybe this map variable can be called tally or something more meaningful, specific for the code. Again, this is one of those things that you can talk to the interviewer about and let them know that you're thinking about these things. And that's very, very important. Again, as long as you're thinking about that and you're telling the interviewer that you're considering these things, you're getting full marks for it. Let's keep going. test your code. Check for no params, zero, undefined, null, massive arrays, async code, so on and so forth. And we kind of covered this in the previous step, but you want to just check with the interviewer that we're making some assumptions here, but let them know that you're thinking about it. You're thinking about the fact that this function might not always be run with 2 arrays. How can we test this function, and how would you test this function to make sure that it gives the expected result, that we always return true or false? And this is where you might say that you're going to test your code and run some unit tests. Finally, even though I say finally here, there is another point, but finally, talk to the interviewer where you would improve the code. Does it work? Are there different approaches? Is it readable? What would you do, or what would you Google to improve? How can performance be improved? Well, looking at this code, I can start telling the interviewer that, okay, the downside to this solution is that, well, only numbers and strings and booleans can be used correctly because we're using an object, especially in JavaScript, and adding properties A, B, C, and X to this object. Now, object properties, especially with the way we're using a JavaScript object right now, might not work if we're using non-literal values, maybe not strings, maybe a JavaScript expression. And you might also argue that this code could be a little bit more readable. For example, although this code is better in terms of time complexity, when it comes to JavaScript, there's actually a more readable, cleaner way of doing this. Let me show you. This is something that is language specific. That means depending on how much you know about the language that you're working with, you might be able to use methods to simplify this process. So you can tell the interviewer, I would Google specific methods on, let's say, arrays to see if I can just clean up this code and make it readable. For example, I can do this exact same function, and we'll call it contains common item 3, that takes in array 1, array 2, and in one line, I can just return array1.sum, which is a new feature, I think ES6 with JavaScript. And I can say item using arrow functions, which come with ES6. And I can say loop through array2.includes and check if it includes the item. Oops, not that item. Now, what do we just do here? Well, we're using some built-in JavaScript methods to do essentially what we've done above, which is check the first array, iterate through each item in the array, and if some of them include the items in our array 2, just return true or false. If we actually check this with our array, and I run this, and let's comment out the first one. If I hit play here, oh, I got to make sure that this is includes, not include. I get false because our array doesn't have any matches. If it does have A and A matched, I get true. Look at that. I just created a nice little function using JavaScript here. How cool is that? This is what we talk about when we say there's different solutions to a problem. We now have a way to measure different solutions to a problem. We can say that there's actually another solution using some of the built-in methods that comes with JavaScript that is, some would say, more readable, more concise. If you're working on a team that really knows their JavaScript, this is a lot easier to read than this, right? So maybe readability is more important. You might say that this is a better solution. Another thing you may have noticed is that we've talked about time complexity here. And we haven't really talked about space complexity. And this goes into a final point. If your interviewer is happy with your solution, the interviewer usually ends here. It is also common, though, that the interviewer asks you extending questions, such as how would you handle a problem if the whole input is too large to fit into memory? Well, if we talk about space complexity here, we can see that in the first solution that we had, let me comment this out, we have space complexity of O1. Because we're not creating any new variables, we're just using the inputs, arrays. Technically, additional space complexity for our function is O1. It's constant. But if we scroll down to this one, well, we're creating a new object here. And we're adding the first array into an object, which takes up memory. So this solution actually has space complexity of OA, which is the first array, space complexity. So if an interviewer says if there's limited memory or memory is expensive, you can just tell him or her, well, this solution, although faster in terms of time complexity, is more heavy in terms of space complexity. Now, this point here that we forgot to mention is something that, again, is really good to mention during your interview. Modularize your code from the very beginning. Break up your code into beautiful small pieces and add just comments if you need to. What does that mean? Well, we have the solution over here that we've worked on, and we've commented it out. We've modularized, saying that this first block of code is going to do something, then this block of code is going to do something else. But as code gets more and more complex, it becomes increasingly important to write in a modular way. That is, small bits and pieces that read like English. You see, long, really hard to read code costs companies a lot of money because it's not just you working on a code base. It's most likely tens, hundreds, if not thousands of developers and engineers. So companies want to hire somebody that is able to write clean code that is readable, that is easy for anyone to pick up and code along with. For example, here, what we might want to do is actually separate these out into different functions. Maybe creating a function in here that perhaps says map array to object that receives the first array item. And then maybe here another function to the outside world that says compare array to object. Now, you don't really have to do this during an interview, but it's good to mention it and talk about the idea of modularizing your code. If a function is doing too many things, that's not ideal. When we say modular, we want to build small pieces of code that do one thing and one thing really well. Ideally, a function takes an input and returns an output, and inside of that block does just one thing. If it has to do any extra actions, well, perhaps you have another function that lives on the outside world, and this function also does one thing really well. And this creates really testable, clean code that is modular. Again, something that is really good to mention and talk about in your interview. Whew. All right. I know this is a lot, and it's a lot to think about because now you start thinking, am I going to have to worry about each code that I write and analyze it this deeply? No. In your day-to-day life, you're not going to do that. But I wanted to demonstrate to you that this is the kind of thought process that really good developers have and what companies are interviewing for. If you're able to think clearly through these steps, like I have outlined for you, and you're able to solve problems this way, you see how much more impressive it is than if I just wrote down this solution without any explanation. Even if you don't get to this part and time runs out during your interview, you've demonstrated to your interviewer that you're able to think clearly. You have the fundamentals to think like an engineer. And these are great qualities that companies love to hire for and skills that are very rare. I hope you had fun with this exercise. You might have to come back to these videos later on. But for now, I'll see you in the next one. Bye-bye. Hello! I know. The last two videos were kind of long, very technical. If you weren't familiar with JavaScript, maybe they were a little bit tougher. But the point was the process of solving a problem in a coding interview. And over here, I've created a little playground for you. You remember the Google interview video that I made you watch? Well, I've implemented the solution that the interviewee created in here. We have the naive solution, which is the nested for loops, and then a better solution that uses just one for loop at the expense of creating something in JavaScript called new set. I left this here for you to play around with, and if you want, code it in your own language. But I wanted to challenge you to see if you can implement this on your own, just like the person in the Google interview did in your own language. The naive approach and then the better approach. And try to follow these steps as you code along. Even though you already know the answer, even though you have watched the interview video, by practicing the steps and how you go from the naive to the better solution, by following these steps, you're going to improve that interviewing muscle. All right, I'll see you in the next video. Bye-bye. All right, another section done. And in this section, we talked about the technical interviews and how to solve problems specifically. One big misconception is that you're either a good problem solver or you aren't. But as with anything, it's a muscle that you can train, that you can practice. So with enough practice and knowing the tips and tricks that we covered in this section, you can solve problems a lot better. That shows the interviewer you know what you're talking about. The key in this section was this cheat sheet and the step-by-step walkthrough of a problem. We looked at how a Google interview might look like, and then we mimicked some of the techniques used there to solve our own problem. The idea was to show how you work. Think out loud and try to comment the steps as you go along to solve a problem. Communicating throughout the process as much as possible and not worrying about finishing a problem fast is the key to interviewing and solving problems in an interview. Now, we should have also gotten the idea that we don't want to memorize problems. Because if you do 100 problems and try to memorize them, well, it won't really help you long term. But you're also taking a gamble, right? You're hoping the interviewer asks you a question that you've seen before. Instead, we want to take control of our destiny and practice and be ready for anything by building the fundamentals. We talked about how by using the Big O and the lessons we learned here, we can now move on to data structures and algorithms and use them during our code interviews. We also talked about some of the skills that interviewers are looking for and demonstrated how it wasn't necessarily just coding skills. There's a lot of other aspects that interviewers are looking for. And we covered these items and how to show them during our practice interview question. Finally, we're now ready to dive into the exciting part of data structures and algorithms. We have a nice foundation, and we know that all we need is to learn these data structures and algorithms to really be interview ready. And we're also going to be using the cheat sheet that I gave you in this section throughout the rest of the course. And at the foundation of this cheat sheet is the idea of readability of code, space complexity of code, and time complexity of code. And although we didn't cover everything in the cheat sheet, we have a few items here at the end. You'll see that as we go through the data structure and algorithm questions, certain type of patterns will emerge. That although questions may be different in an interview, usually the way to optimize things or tricks to make your answers better can be narrowed down to specific steps. So don't get overwhelmed. There's an easy, clear checklist and heuristics that we're going to go over later on. But by this point, I think we're ready to move on to data structures and algorithms. How do we write good code, create good programs, create value for the companies that we're interviewing for? See you in the next section. Bye-bye.